The question reads, a 60-watt filament lamp is powered by 240 volts mains electricity supply. The lamp is switched on. Calculate the current in the lamp. Now we are given with the voltage over here, and also the power of the filament lamp is given to us, and we have to find the current. And there is a formula which joins all these three quantities, and it is the basic formula of electric power. That power is the product of voltage and current. So 60 is equal to 240 times current, and current is going to be equal to 60 divided by 240, which would give us an answer of 0.25 amperes over here. Then we have to find the resistance of the lamp, and since now we know the current and voltage both, so we can also use the Ohm's law equation. So resistance is equal to voltage divided by current. Voltage is 240 divided by the current of 0.25 amperes, and it gives us the value of 960 ohms. So in the answer space, I'm writing 960 ohms. The next part reads, the lamp is now unplugged from the main supply and connected in series with two 1.5 volts cell. So this is the first cell and the second cell. Figure 6.1 is the circuit diagram. This is the lamp, two 1.5 volt cells. Then there is a voltmeter connected in parallel with the lamp to give the voltage reading of the lamp, and there is an ammeter to show the current flowing through the circuit. State the reading on the voltmeter. So the voltmeter would be giving the voltage of the lamp, and since this is the only component connected in the circuit, so the total voltage would be appearing across the lamp. We have two 1.5 volts cells connected in series, so the total voltage being produced would be 3.0 volts, and the same reading would be shown by the voltmeter. So I'm writing 3.0 volts over here. The next part reads, state and explain how the resistance of the lamp now differs from the value calculated in part A2. So in the previous part, we calculated the value of resistance as 960 ohms when it was connected to a voltage of 240 volts and a current of 0.25 amperes was flowing through it. Now it is connected to a voltage of 3 volts, and by connecting to a lower value of voltage, we have to find how the resistance of the lamp has changed now. So the first thing is its resistance is smaller, and the reason is due to the filament is at a lower temperature. So when the voltage increases, that also increases the temperature, and at the higher temperature, the filament of the filament lamp, its resistance increases, and when the voltage goes down, the resistance decreases because of the decrease in the temperature. So the voltage has decreased, we can see it, which means the temperature is going to decrease, and with the decrease in temperature, resistance is also going to decrease. The last part says when a filament lamp blows, it very often does so immediately after being switched on. Suggest why this is the case. The reason for this is that the filament is cold and has a very low value of resistance. So initially when it was switched off, the temperature was very low for the filament, and because of being at low temperature, the resistance was low. And at a very low value of resistance is allows a large current to flow. And because of this current surge, it immediately blows. So this is the reason why it blows immediately after being switched on. So the main reason here is the current surge, and the surge of the current is caused by the low value of resistance, and the low value of resistance is because the filament is cold initially.